In this question, we are going to take a look at velocity and acceleration and drawing them on a graph. On the test, you're also going to be responsible for graphing the curve. Usually, you will be given a interval of values for t. Let's just say that the interval is between -3 and let's say +2. And then you will have to fill out a table of values where the first column will be t, so -3, -2, -1, 0, 1, 2. And then over here, you're going to have x and y. And then you have to substitute those values. First, the t values you substitute into the x component and then to the y component. So for the first one, we're just subtracting 3 from each one. So -5, -1, there will be -4, -3, -2, -1. And then for the y component, we want to square each number. So this will be something like 9 plus 2, that's 11. Then over here, -2 will be squared, that's a 4 plus 2, so that's 6. -1 squared, that's 1 plus 2, 3. This will become 2. This will become 3. And then 2 squared is 4 plus 2 is 6. Okay, so maybe I shouldn't have taken -3 because that was going to be off my grid. But let's just say we want to graph it. So let me make the axis here. And then you would do this on your paper. Okay, so let's just put the points, and each point over here has to be on the graph. So I will just make this -3 to be -2 and then cross this out because this is off the grid. Okay, so for my graph, I need to completely disregard the first column and just graph the x and the y. So this will be -5, and each point should be very clearly labeled on the graph. So I got -5, +6. 1, 2, 3, 4, 5, 6. So this is my first point. -4. 1, 2, 3, 4. And then that would be 3. That's my second point. -3 would be +2. -2 would be 3. And then -1 would be 6. So this is a parabola. Now, if it that gives me this range of values, you should not continue the parabola, because it's only between, if the t is restricted between -2 and 2, then you end right there, you don't continue. But if t is not restricted, then it would be the whole parabola. You should also indicate the direction of motion. So if I am starting at -5, 6 and go towards -1, 6, the direction of motion is going to be like this. Okay, so I graphed it. Now, what else they want me to do is find the velocity and acceleration at time t. Let's see if I can do that. Let me put them together. So for the velocity, I'm going to take the derivative of the position, which is going to be 1 and 2t. For the acceleration, I'm going to take the derivative of velocity, which will be 0 and 2. Okay, so that's going to go in here, 1, 2t. Then this would be 0 and 2. Next, I want to compute the same thing, but I want to compute it at -1. So this should be 1, -2. I'm just plugging it into the t. And acceleration does not depend on t, so that's just 0, 2. Okay, so next what I need to do is draw the velocity and acceleration vectors on the graph. Now, what happens at t equal -1? Where is the particle going to be at t equals -1? So let's look at it. So I want to draw the velocity and acceleration at t equal -1. So whenever t was -1, the point I had was this right here. So this is -4 and 3. So you will have to figure that out on the test. So you got -4 and then +3. So this is the point where you're going to start your vector. And then the vector at -1, the velocity vector is 1, -2. So you are starting right here at that point, and you are going 1 to the right and 2 down. And your vector, so 1 to the right, 2 down, will be this one right here. and that's the velocity vector. Okay, so this is your vector v. Velocity vector is always tangent to the curve, and it is always shows the direction of motion. So the direction should be the same as we were drawing those arrows, and the same thing will happen with vector v. The acceleration, again, you start at this point, at the same exact point. You do not go right or left because the x component is 0, and you're just going to go up by 2. And so the acceleration vector will be right here. That would be the acceleration. Okay, so let's see if we can draw the same thing over here. So we start, and we want to start over here. We draw 1 to the right, 2 down. So 1 to the right, 2 down. That will be this vector right here. Now, for the acceleration, because you have to start it at the same point, if you try to do it, it thinks that you want to move the first vector. So I would just start above and draw it first like a small vector, which is incorrect, but then change the initial point by dragging it over here so that they can coincide, okay? And that's going to be my answer. So I drew the velocity acceleration. I don't think it wants you to draw position. If it did, you would start at 0, 0 and end at the point right here, right? At this point, -4 and +3. And the final thing that we need to do here is find the tangential and normal components of the acceleration vector. How do we do that? So let me remind you what we do. So first of all, for the tangential component, what we want to do is we want to really find the component. So this is called AT. This is the component of the acceleration vector at -1. And onto the velocity vector. So what that means is that you're going to be just dotting the acceleration and velocity and dividing by the magnitude of velocity. And you are doing it specifically at -1. So the vector of acceleration was 0, 2. Vector of velocity was 1, -2. And then you are dividing that by the magnitude of velocity. So that's 1 squared plus 2 squared. So the tangential component should be -4 divided by square root of 5. Now, for the normal component, the formula looks like this. You take the square root, then you're going to have the magnitude of the acceleration vector squared, subtract the tangential component squared. So let's see what will happen. So for the magnitude of A, that's just going to be 0 squared plus 2 squared square root, but that's just going to be 2. So this is 2 squared. Subtract whatever this thing is squared. So that will be 16 divided by 5. And so just to make this a little bit nicer, let's see if we can simplify this. So 4 is really the same thing as 20 divided by 5. So I'm bringing that to the common denominator. So that'll become 4/5 square root. If I take the square root, that'll become 2 divided by square root of 5. Okay, so let's see if we can put that in. So it does it want in the, oh, it wants to round to 2 decimal places. So the tangential component was -4 divided by square root of 5. So let's go ahead and compute that to 2 decimal places. Okay, so that would be -179, -1.79. And then the normal component, we got 2 divided by square root of 5. And that is 0.89. Let's see if that's correct. Yes.